Hi, and welcome to PROSTEP's presentation of a discussion on engineering standards. We're here to talk about the benefits and potential drawbacks standards can impose on your engineering processes. My name is Joseph Lopez, PROSTEP Inc. Marketing, and we have with us Brian Scouten, Director of Technical Presales at PROSTEP Inc., and Joachim Boy, Senior PLM Solutions Consultant and Standards Expert from PROSTEP AG.
So in this roundtable, what we'd like to explore is some common engineering standards for data exchange, as well as neutral formats for other purposes, how they interface with 3DExperience, and then, what's effective about them, how do they become standards, and when to use them, and if they might do more harm than good.
Yeah, and we'll also have a quick look at why there are so many different standards and where it's good to have a single standard and where it might be more beneficial to have a smart combination of smaller standards.
I want to start with a little PROSTEP overview, talking about PROSTEP and also the PROSTEP ivip Association, then review some of those standards that we're talking about in engineering, and then have a discussion and discuss some common topics around those standards. So PROSTEP is an independent company specializing in integration and interoperability with engineering data. We were founded in 1993 out of a consortium in Germany and have ownership that looks like the major OEMs and tier one suppliers of automotive. So it was costly and difficult to exchange data back then. PROSTEP also is a member of different organizations within the standards field that includes the PROSTEP ivip Association, but then also the Object Management Group, and the 3D PDF Consortium, VDMA, and others that are important in engineering standardization bodies. And we work closely with them in order to try and develop and implement these standards.
Yeah, the one standards body that has been mentioned a couple of times because it's really close to us, of course, is the PROSTEP ivip Association. Yeah, so on the one hand side, you have the PROSTEP group, which is a PLM specialist and will help you with integrating your customers and your products and your processes. And then on the other hand side, there's the PROSTEP ivip Association, which is a non-profit membership organization. Next slide. So PROSTEP ivip was also founded in 1993, and as you can see from a quick glance at the icons on the right-hand side, basically everyone who is working in the manufacturing industry, be it airplanes or cars or ships or general machines, they are a member of us and work out on how they can best collaborate. So just to give you a few numbers that go with PROSTEP ivip. So of course we also work together with others, partner bodies such as ISO or OMG, to create and distribute those standards. We have about 190 members. There are 29 active project groups. So there are industry-driven projects where requirements on standards are gathered. We have projects where actually the standards are being developed, and then at least as important, there are implementer forums where those standards are implemented in the software tools so that you can actually go ahead and use them. Obviously, PROSTEP ivip is also doing a lot in the area of public relations and making the standards known. So there are events and webinars and publications, and whenever you are interested in participating in one of these, just go to the prostep.org website and there you can find more information. So the goal here is basically to support the entire product lifecycle and product development cycle with a combination of standards. So it starts with requirements and systems model, and it spans project management, your classical engineering domain, behavioral model, functional data, electrical wire harness, kinematics. It goes on to cover production with automation ML and additive manufacturing data, and then quality inspection, up to long-term archiving. So you can think really of it as kind of an infinite cycle. So once you have a product finished, you're actually already in the development of the next generation of your product. You can combine these standards using a digital data package. And just one example there is the smart systems engineering, which particularly talks about how can you collaborate in the systems engineering area using standards such as SysML or the functional mockup interface.
So PROSTEP is also technology partners and service partners with all the major vendors of PLM and CAD and others like PDF and visualization and ERP, ALM, and other types of systems as well. And this makes us kind of a neutral player in this field, right? So we're able to communicate and have commercial adapters for these different products that allow us to interface to these systems, including Dassault, and then a long history of that partnership. So going back to the Matrix 1 days, having adapters for that, as well as very good technology with the legacy VPM and LCA and now COExperience and Innovia products. So we've been a long-term partner with them, supporting those PLM systems. And then we also have other CATIA related integration tools and interoperability tools, allowing for data from CATIA to be interrogated and used in different ways, right? So committed to different repositories or using interoperability, as well as being a service provider and integrated with aerospace and automotive systems and helping provide those services. So our core focus area is always in the leading edge, right? So whether it's this ALM, PLM, ERP, MES, MRP type integration, systems engineering integration, digital masters, digital twins, in strong collaboration to try and bridge the gaps between different corporations or different systems and silos within these organizations. So with that focus on the commercial side of PROSTEP, then we also leverage some of the standards and know-how of the PROSTEP ivip Association in order to do that, right? So trying to utilize those technologies in order to accomplish those goals.
Yeah, and when you think about standards, it's really worthwhile taking a step back and think about for a moment, what actually is a standard? Where do they come into play and why do I use them in the first place? So a very dry definition of a standard basically just said it's a document that describes rules and conditions for how things are made. And even in everyday life, you have standards. So when you think about a multinational conference such as CO, where you have people from many countries coming together and talk to each other, well, you need to agree on a way how you talk to each other, which may be the English language. Now, when you work together on an IT level, basically it's the same thing. So you may have a complex product at your hand with numerous tools involved in its development. And of course, again, you need something like a common language so that these tools can talk to each other and you can really develop the product and also manufacture the product as it was developed to the applying standards. So types of standards, they may simply cover things like dimensions and structures and also how do I manufacture something so that it really works and doesn't break? How do I test it? How do I analyze it? It may also be terms and abbreviations really agreeing on what is the common language that we use to talk to each other when we work in this area. And then how do you select those standards? Well, in some cases, you really don't have a choice. There are government mandated standards that you simply have to apply to when you want to do something. When you erect a building, you have to comply with the building code that's applicable in your city or country. Otherwise, you wouldn't be allowed to use the building. The same goes for cars, where you have to match certain environment and safety standards. Otherwise, you would not be allowed to use the car. So there are these kinds of standards. And then there are voluntary standards where you really have a choice, where you say, okay, this is the most efficient way of working for me to develop this standard. And so you might think about also what happens if I don't use the standard. So is there an immediate penalty when not using the standard, or is it really more on a business level? Are there business advantages or disadvantages to use them? Because whenever you use a standard, you may have to translate data, which comes at a cost. So you may want to see what's the total cost here when I use the standard versus when I don't use the standard. Also, standards evolve along with technology, and you want to see what's the latest version of the standard that I use. So on the one hand side, not all tools may support the latest version yet, but when you use an older version, you may not have access to all the latest and greatest features that you want to use. And also, when you think about product maintenance and lifecycle support, you also need to make sure that you use the standard in the version that was current when the product was developed when you want to check something. So how many standards are there? This is a question that has many answers depending on the field you're working in. And we want to give you just a small example here, which is taking the viewpoint of the European aerospace industry. So they have what they call the radar chart that you can see here, which keeps track of relevant standards for their area of engineering. And when you read some of these blips, you can see standards that cover many fields. So there are visualization standards. There are really 3D CAD engineering standards, but also you have blips there for requirements, for electrical data. So it's all kinds of stuff. In some cases, they cover very similar things. So there is a 3D visualization. You have PRC, which is part of a 3D PDF, but you also see STEP in there, and there's various standards for that cover electrical. So they may or may not be competing, and it's quite a lot of standards that you can see there. There actually is a very similar radar chart for the Aerospace Industry Alliance in the US, and I know that other industry branches keep track of the standards that are relevant for them in a similar way. But really, this is just a first glance, and you can see there's really a lot of standards to keep track of. But this also gives you the opportunity to choose the standard that is best for your area of application of the standard. And we kind of want to narrow down our talk in the remainder of these presentations to 3D engineering formats that are related to the CAD design. And we've listed a few of the most popular ones here in this area. So of course there is a STEP, which is a long-standing standard for data exchange across companies. And it's also one of the most recommended formats for long-term archiving because it's an ISO standard. So the data model, the specification that is stored at ISO in Geneva, you can get it from there. Also, the STEP files are ASCII files, so they are easy to read and to debug, and it's proven to be a very stable format. So it has its advantages in that area. Then there is JT, which comes from the visualization, the viewing use case, and it allows for very efficient viewing of even complex product structures and doing digital mock-ups in a very efficient way. And so it's also used for engineering exchange, but it has a slightly different area of application in general. So, and these two are actually ISO formats. So you have ISO 10303 STEP, you have ISO 14306, which is JT. Then you have 3D XML, which if you are working in a Dassault environment also is kind of a standard. It's not an international standard, it's an industry standard, but it allows you to work very efficiently within the Dassault environment. And there is a public part and a private part to it. And again, depending on your tool chain and the companies, partners you work together, this might be the best choice for your use cases. And then finally, there's PDF, and in particular 3D PDF or PDF/E, where E stands for engineering, which again has a 3D content, but also can provide a lot of accompanying data. So There also is a viewing use case here, but this is really more in the direction of product documentation, maintenance manuals, and so on, where you can interact with and view with without the need for any specific viewing application, because it runs in an Adobe Reader, which is available on every platform. So that again has its scenarios. So you can see here we have 4 different formats, which at first glance all deal with 3D CAD data, but they all do it in different ways, and they have their different strengths and weaknesses. So this slide probably alone could fill an entire presentation, and if you want any more details on the backgrounds, then please get in touch with us. We have a white paper and many more information, much more information we can give you. So now that there are so many standards, of course the question comes up, what is an ideal standard? What have we learned over time? So there was a time when standards were developed with the idea of creating the world formula, to have everything in one place, a common language for everything. But I think now in the meantime, people have learned that it is better to have smaller standards that very well support their area that they are there for, and then connect these best-in-class standards in a smart way, so that you have your information combined in standardized pieces that work together very well, but each of the pieces is flexible and can adapt to technology changes very well. Of course, an ideal standard should be agreed at an international level. Now, globalization is a very obvious thing. So you have companies in the States working with I don't know how many countries in Europe or Asia, and to make sure that everyone talks together in a consistent way, you need an internationally agreed basis. ISO is the most prominent example, but there are other associations such as the Object Management Group, for instance, that basically do the same thing. So the main motivation for having a standard is to enable the independency of data from tools, that you have stable interfaces, basically that you don't need to change the data when you change a tool. And the tool change, it might be because you go from company A to company B to company C, or because you roll out a new generation of your IT landscape, but you want to keep on working with the existing data. So that's a motivation here. And that goes hand in hand, basically the next point here, which says continuity and consistency. Well, it's across domains, it's across companies, and also it's across IT tool generations, basically. Of course, standards need to be unambiguous, so that if you have a certain use case, there is an agreed way to support it in that standard, because if there is one tool that writes certain information in that way to the standard and another tool writes it in a different way, you have the emergence of dialects, and that can lead to misunderstandings, which are a bad thing, obviously. Standards need to be updated continuously to keep track with the latest changes. And this is then something that is heavily dependent on the philosophy behind the standard. So there are standards that are described in a very formal manner, where a lot of thought is put into the standardization process. So it takes rather long to get a new generation of the standard, which is then very well thought through. There are other standards that have a much more generic or pragmatic approach, where you have a new version of the standard out rather quickly, but then all the harmonization work needs to be done on the tool side, once again, to avoid the emergence of dialects. There is not a best answer there, but those are, again, things to consider when you pick a standard, that you also have a look at how is the standard developed. What are the standards used for? Mostly, well, data exchange and collaboration. So when you go across companies, you go across domains, and then long-term archiving also plays in that, because the long-term archiving basically is a data exchange with an unknown target system. So here is a more humorous look at why there are so many standards. I think this is, in the standards community, a quite famous cartoon. So this is a process that is actually still ongoing. There are new use cases coming up, new tools coming up. There are research projects, whatever, that come up with a standard format. And then once a new industry moves into a certain field, or you get the area, well, I have to combine two areas, two domains that have previously been separate. You start looking at, okay, how can I combine all the various data formats? And there's always a big temptation to say, okay, let's create a new standard that takes the best of everything. But sometimes you really have to ask yourself, is that really the way to go forward? Or aren't we better off to use the standards that are already there and just combine them in a smart manner? Okay, so finally, some closing thoughts is, what standards are there? Think about it. And once again, let's move away from the typical engineering data point of view and take a more everyday pragmatic look at things and think about power outlets. You want to charge your cell phone. What do you use? So you have the 120 volt outlets in the US, you have 240 volts in Europe. When you sit in your car, you have a 12 volt battery outlet. And where does it all come together? What about USB? So you have power banks, you have the USB adapters that are available basically for every cell phone, tablet, or so on that there is. But then again, well, now you have USB, but what kind of USB port are you talking about? Is it type A, type B, type C? Is it micro USB? Is it mini USB? So it's a standard, but then once again, not really a standard. And then also we talked about how long does it take to create a standard. So let's have a look at the topic of long-term archiving. So this is an organization, an international project that started many years ago, actually, to develop standards for long-term archiving in the aerospace industry. So when you look at the project timeline, it actually starts in the late 90s, when the first idea that such a standard is needed to move away from archiving engineering drawings towards archiving real 3D engineering data with all that goes along with it. And then the project was formed in 2003, and then in 2006 the first LOTA parts were published. So you have the EN 9300 in Europe and the NAS 9300 in the US. So that was published 14 years ago, really defining the framework of the standard. And then as time goes by, more and more parts of the standard series have been developed. So we started with the CAT geometry and the PMI, which is something that is now finished, but we're moving on towards PDM and composites and electrical and systems engineering and so on. So when you look at the LOTA standard as a whole, will it ever be finished? Actually, I don't know. When you look at individual domains within the LOTA standard, yes, then we are finished. And it, on an industry standard on that scale, it typically takes a few years to develop, but after that, it's really stable. So once again, you have to weigh the pros and cons. Is it a bigger standard? It obviously takes longer to develop. It might be more stable in the long run. If you are talking about a very specific application domain, you may reach consensus in a much faster way, but then you may have to combine several standards, which again takes time. So as you can see, there is no one easy answer to that.
So now we'd like to get into some standards discussion and maybe talk about some common topics within the standards.
So I have a question that I was just thinking about in terms of standards, and this is for the both of you. How are standards viewed in Europe versus the US and in Asia? Do certain geographies follow standards more than others, and how does that play into just communicating information across the globe?
So I can take an implementer's perspective on this, and I think that the standards are used more within specific implementations of software, depending on the region that they might be coming from. So there's bodies that like aerospace bodies, automotive bodies, and they have specific standards that they've lined up. And I think generally between European and North American, that's pretty consistent. And globally it's fairly consistent. But I think the implementation of those specific domains, might be regionalized a little bit too. And maybe as a standards coordinator, Johan, you have a different take on that?
Well, yeah, not necessarily on the IT level, because I think that has been very international from the get-go, and there aren't that many differences between the US and Europe when it comes to that respect. But when you think about engineering standards in general, I think in Europe you have a more open mindset towards that, simply because we have a lot more different countries on the same area basically, and you get on an international level much faster here in Europe than you get in the US. So it's kind of a tradition thing, that whenever we talk about even things like railways and cars and so on, you immediately have to think on an international level, and that is probably something that then again proliferates into the area of IT and work. Okay, how do I exchange data on an international level? Internationalization, how many different product names and how many different languages do I have to support in my data, and so on.
And so that kind of, follows the next question. Are all standards pretty much open, or do you just have one proprietary company creating proprietary standards? And how does that play into that on a global scale?
That kind of depends on the individual history of a standard, I would say. So there are standards that have been created on a whiteboard, basically, and with the idea of being a neutral standard from the very first place on. So STEP, for example, is one example there, where really everyone has kind of the same voice and can get involved on the same level. Then there are other standards that started off as a proprietary format and then became standards later on. Some of them are industry standards, so they are still owned by a company, but they're open for everyone to use. And I think one of the most famous examples for that is the zip format. And then there are other standards that also started off as a company standard and then became even an ISO standard, just like PDF.
Can either of you touch on what makes a standard successful and why we would use why are standards good and why are standards bad?
I guess for systems engineering integration, for standards to be successful, for me, they have to be easy to implement, right? So they can't make your job more difficult. And sometimes, trying to read that and write it into like the correct information model is difficult, right? Instead of conveying it easily through simplification of what that original, information might be.
Yeah, I would totally agree that one measure of success of a standard is how widespread it is supported in applications. Because really, a standard as a turntable for information basically really benefits only when there are many different applications that can read it and write it, so the standard itself becomes a backbone for implementation. So on the one hand side, you need the acceptance on the implementation level so that companies don't have to invest humongous sums to actually support the standard in the first place. And then you also need the acceptance on the user end, which mostly comes down to features and performance. So does the standard support the things I need, and does it support them in a reasonable amount of time compared to when I just use the native data?
Yeah, well, thanks for joining our presentation. We hope you found it informative, and we certainly appreciate, being at the COE and presenting on the Standards Roundtable. And thanks to everybody involved, and Johan and Joe as well.